My screen is visible?
Yes, sir, it is visible.
Your voice is a little low. Am I audible properly?
Yes, sir.
Yes, sir. Yes.
Okay. So Cascade, H bridge. So till now, what we have seen, we are having a PV. Then we were using DC to DC converter, and here we wanted to use our cascaded H bridge, correct? And then we are having
Yes,
our
sir.
load. So earlier we were using 2-level inverter, and that was something like this, right? And let us suppose this is 1, 2. Three, 4, 5, 6. So something like this. It is a 2-level inverter where we are having a VDC, which is VDC is this voltage, and output you were getting as only in 2 levels, that is either in plus or in negative, right? This can be VDC, this can be minus VDC. But now
Yes.
in order to improve or in order to include the novelty, we are planning it to replace it this 2-level by 5-level. How does this 5-level looks like? So it looks like somewhat like this. It looks like where this is, yeah, this can be your VDC or 2 VDC, whatever you want. This can be your VDC. This will be again minus VDC, and this will be minus 2 VDC. Okay, and you can count the number of levels. This is level number 1, 2, 3, 4, and 5. So there are total 5 levels, from which it is taking 5 levels to go from positive to negative. So that is why we are calling it as a 5-level inverter. Now there are many advantages of 5-level inverters. One of the advantages is that if you can compare both of their THD, that is total harmonic distortion, that the total harmonic distortion of 5-level will be less than 2-level. So that means passive components requirement will be less, because ultimately you have to convert this square wave to a sinusoidal wave. That means you have to filter out the higher order harmonics, and then you will be requiring to make a filter, and you will make that filter by use of a passive components, either by LNC, right? And if you use LNC in this passive component, so here, since the harmonics will be more, so the size of these passive elements will be more, correct? And if you look in this 5-level inverter, so total harmonic distortion will be less. That's why we will be requiring or the harmonics will be towards the higher order. That means if 50 hertz is our reference signal, so other harmonics maybe can be at 250 hertz, like this, or 500 hertz or 750 hertz. And the magnitude will also decrease because the overall harmonics profile is less. So in this way, since the THD will be less, so you will be still requiring filter, but in this case, the sizes of the passive elements will reduce. Sizes will reduce, right? So the sizes will reduce. What is the second advantage? If you can focus here, just see. It is directly switching from this VDC to minus VDC. So that means voltage stress on the switches. Suppose if the switch 2 is on, then again switch 2 has to turn it off. Then you can see voltage stress, that is VDC plus VDC, that will be twice VDC. So voltage stress on the switches will be more. Whereas if you compare this with the 5-level, so after VDC it will go to maybe VDC by 2, and then it will go to 0, then it will go to minus VDC by 2, then again minus 2 VDC. So you can see the voltage stress is reduced. So these are the two main advantages, you can say, why we want to go for 5 levels. And there is a specific power level for which we will use our 5 level, right? Because for lower power, this 5 level will not be that much useful. Lower power will not be useful, because if you see in your home, if you are having an inverter, so that is it might be connected to a battery, and that will be generating the output voltage in 2 levels, right? So that 2 levels are because the sizes of the filter there will be less, because it is operating at lower power. It may be 1 kilowatt or 2 kilowatt or maybe 5 kilowatt as well. So before applying it, you should also see or search something about the power level of 5 level inverter. What is the power level? Suppose it is 5 kilowatt or 10 kilowatt or 50 kilowatt. What is the power level? And then once we decide the power level, suppose if we decided 50 kilowatt, then we will design our PV system with 5 level for this power level. Okay, because this 5 level is not useful at every power level. If you go for higher power level, suppose 1 megawatt or 10 megawatt, then there are other converter topologies which are there, which is generally used, right? So this is used in medium power level. These multi-level inverters are used in, these are called as multi-level inverter. Multi-level inverter, they are used in medium power. So you should be very focused about what is the power level that you want to use. This much is okay?
Yes, sir. So we could go ahead with the 50 kilowatt system, right? That we are
that you search little bit more. Okay.
Okay, sir. Okay, sir.
Okay. Now coming to the topology. So in multi-level inverter, as we have already seen, there are basically 3 kinds of topologies. First one is CHB, cascaded bridge. Second one is neutral point clamp, and third one is capacitor, flying capacitor, right? So these are the 3 topologies. Apart from this, also there are hybrid topologies, which if time permit we will see. If not, we will avoid. So first we have finalized that we will go for CHB. Now I will just show you how this 5 level CHB looks like. So if you go with a basic level, in not 5 level, just a 3 level, so you can see there is a load. Let us suppose plus minus. This is VDC. So you are not having any class or anything, right?
Yes, sir. Yes, sir.
Okay. You can switch this as number 1, whatever you want to give the number. Generally it is 1, 2, and 3 and 4, and you can connect an anti-parallel diode to it, because this anti-parallel diode is already embedded on the switches. Generally in multi-level inverters, we will use IGBT as our switches. That is insulated gate bipolar transistor. This we will use because these are basically useful at medium power. Whenever we are dealing with power electronics, so power is a very important term. That is why I'm focusing more on power. So whatever system you are designing, whatever thing you are doing, whatever research you are doing, you should be clear, absolutely clear, that this is a power level. That is why, because we could have used here MOSFET as well. We could have used here transistors as well. Right? So there are many devices which are available in the market, but I am specifically saying that we will be using IGBT because it is most useful at medium power. Medium power can be in a range from 5 kilowatt to 50 kilowatt or maybe 100 kilowatt as well. Okay, so when you see this topology, so how 3 levels will look like? 3 levels will look like this. So this is how 3 levels will look like. Here an introduction of 0 level is also there if you pay attention. So this is, you can say, plus VDC, this is minus VDC, and so this is 0 level as well. So this is first level, this is second level, and this is our third level. Therefore we are calling it as a 3 level. Now how to get plus VDC, 0 and minus VDC there, because there are only 3 voltage levels. So plus VDC you can obtain by switching switch 1 and 2. 0 VDC you can switch by switching 2 and 4 or 1 and 3. and minus VDC you can get by switching 3 and 4. Okay, these if you switch this accordingly, then you will get 3 level as your output voltage. Now,
Sir, actually, I had a doubt, like when the zero level will be like when we will be operating in zero level thing, then the output voltage will be zero, right? Like the system will turn off. Is it so?
yes, this 0 level, correct. Correct.
Okay, sir. Okay,
Correct.
sir.
So system will not turn off. No devices will be turned on. You will not provide any pulses.
Output voltage.
No, output voltage will be 0. That is okay. But you will not provide any pulses to the switches 1, 2, 3, and 4.
Okay.
That is why you can see if you switch on 2 and 4, how the current will revolve. Current will move through this IGBT and through this anti-parallel diode through this load.
Okay, sir.
Then you will be getting 0 voltage. If you look for above 1, that is 1 and 3. If you switch on 1 and 3, so this 3 will go like this. Okay.
Okay, sir.
For 0 level. Now we will see for 5 level, which we are planning to do. Now I will not draw an anti-parallel diode. You must assume that it is there. The 2 cascaded edge bridge connected back to back, and I think this will be load, and this will be again connected to here, and this will be connected like this. So this will be plus minus. You can call it as a load, or you can connect as resistor as well. So this will be, let us suppose VDC again. This is VDC again, and let me call the devices as 1, 2, 3, 4, 5, 6, 7, 8, right? And so these are the connections. So now the waveform, how will it look like? The 5 level that I have already told. Okay, so this thing you can consider as VDC, and this will be 2 VDC. So how many voltage levels you will get? One voltage level will be 2 VDC, then VDC, then 0, then minus VDC, and minus 2 VDC. So that is why we are calling it as a 5 level. Is it okay?
Yes, sir.
Okay. So now if you want to get suppose 2 VDC as in an output, switch 1 and 2 from the first bridge and 5 and 6 from the second bridge. That means 1, 2, 5, 6 should be switched on at an instant. Then only you will get 2 VDC. That means this voltage level.
Okay, sir.
Okay.
Sir, actually, we have read that like while we were searching, it was written that it is using plus minus VDC by 2 instead of 2 VDC. Like to create 5 levels, it was using plus minus VDC by 2 and then VDC. So like,
so you are saying, so you are saying here it will be VDC by 2 and here it will be VDC, right?
Yes, sir. Yes.
Then what you can do, you can divide this by 2.
So, sir, it is the same thing.
Same thing, correct.
Okay,
same
sir.
thing.
Okay, sir.
Whatever you want, you can take. Okay.
Okay, sir.
So let us just take VDC. So this will be VDC and this will be 2 VDC. So for VDC for getting VDC voltage at an output, you can switch 1 and 2. Now if you switch 1 and 2, then VDC you have already got. That means from second bridge, what you need to get 0 voltage. So 0 voltage, yes, you can get either by switching 5 or 7 or 8 or 6. What you can switch anyone, 5 or 7 or 8 or 6. So let us switch 5 or 7, right? Because you can see 0 voltage how we are getting by switching out either the topmost device, that is these 2 devices, or these 2 devices in H bridge. You can get 0 level.
Yes.
So similarly we can get, you can see here. Then we will get for 0 voltage level. Now top should also provide 0 and bottom should also provide 0. So you can switch 1, 3 and 5, 7. Similarly for minus VDC you can get by switching 3 and 4 and 5 and 7. Again 5 and 7 will give 0 and 3 and 4 will give you minus VDC. And minus 2 VDC you can get by switching 3 and 4 and 7 and 8. Okay, this is how you can.
Okay.
Okay. Now if you switch on this, then you can see that at this voltage level there is one minute thing I am telling you. if you see on this level, let me call this the DC source 1 and DC source 2. Okay, then at this 2 VDC, DC source 1 and DC source 2 both are utilizing. If you see at this voltage level, DC source 1 is utilizing only DC source 1 is utilizing. If you see here, no one is utilizing. If you see at this level, again DC1 source is being utilizing, and if you see here again, DC1 and DC2 is utilizing. So you can count how many times DC1 is utilizing and how many times DC2 is utilizing. So DC1 is utilizing how many times? 1, 2, 3, 4. 4 times. And DC2 has been utilizing 2 times. Okay. So if you switch here in this way, that there might be possibility if you are using a battery here, then this battery will drain out soon or fast. Right? Because we are using DC1 more as compared to the DC source.
Yes, sir. Yes, sir.
So this battery, because ultimately you have to provide some source, correct? And that to a DC source. And in this cascaded edge bridge, generally isolated DC source are provided. Isolated DC source means you can take an example of battery. Okay. Or
Yes,
if you are using a capacitor to divide the voltage after the rectifier. Suppose if you are having an AC source here and then you are using a rectifier. Let's see, you are using a rectifier and you are generating a DC. Then 2 capacitors will be needed. First will be gone to the first edge bridge. Second will be gone to the second edge bridge. This also you can do. But here, if you use again, if you use DC source 1 4 times compared to the DC 2 source twice, then there will be unbalancing of the capacitor voltage.
Yes, sir.
So this is one of the drawback of this. So you have to switch here in some way such that this DC1 and DC2 should be utilized at 50%.
Sir, why cannot we use the same DC source? Like, is there any reason behind like why?
Same DC source means because you have to provide 2 DC source to get 5 level. If you use only single DC source, then you will get 3 level. Na? We have seen here.
Yes, sir. Yes, sir.
You can see only single DC source we have used. But in order to generate 5 level, 2 DC source we are using. For 7 level, 3 you will be needed. For 9 level, 4 you will be needed.
Okay, sir.
If not DC source, if you are using a rectifier and you are connecting a capacitor, then 2 capacitor will be needed. Okay. Then also there will be unbalancing of capacitor. So 50% utilization has to be maintained for efficient and reliable operation. So you just search about this as well, and you try to simulate this topology. And later on, if you can search and study by your own, we can discuss more about this. Okay.
Okay.
Any doubt anyone is having in this?
Sir, for minus VDC we can change, like we can use 1 and 3 instead of 3 and 4, and instead of 5 and 7 we can use 7 and 8. Then
Yes,
we get 50%.
yes, that we can do. That we can do. But again, see, that is a good suggestion. But you see here, the width of the pulses has to be equal. Then, are you getting my point? If the width is different, then again there will be a problem of unbalancing.
Yes, sir.
You just check on this, right? Width of the pulses has to be same. Then there is another problem that you have to match the width, or you have to find that the control strategy which can produce same width, right? Or you have to search some alternative method how you can maintain the voltage balancing between the capacitor or the DC sources. If you are using DC sources, 50% utilization has to be there. If you are using capacitor, if slight changes is there, then this capacitor will charge more. Top capacitor will discharge more. So there will be unbalancing of capacitor voltage. Okay, so you can search on it.
Can we do one thing that we can use a higher power voltage source in first, like V1, and then
yes. So you are saying you can use bigger battery.
Yes, sir. Yes, sir.
Then cost will be more. That is not a solution for engineering student, because you have to reduce the cost.
Okay.
Suppose if you are able to do the solution with one battery which is costing 10,000 rupees, why will you invest 20,000?
Okay, sir. Okay, sir.
So you have to come up with some innovative. This we will focus on later on as well. First thing is that we need to simulate this simple topology, right? So
Okay,
this is
sir.
our first
Sir,
target.
and how we will be connecting our like the past project with this 5-level inverter?
As
Just
I've told
we,
you,
yes, sir.
that here we will be using Cascade. So up to this point, there will be a DC link, right?
Yes, sir. Yes, sir.
And after the DC link, I have shown you in a rectifier circuit
Yes,
that
sir.
there will be two capacitors. So we will,
Yes,
instead
sir.
of using single capacitor, we will use two
Two
capacitors,
capacitor.
and then output of each capacitor will be flowing to the DC source.
Cascade.
We will try this way. If it does not work, we will see.
Okay, sir.
Okay,
Okay,
sir.
sir.
Any more doubt from anyone?
No, sir.
Okay, so you can simulate it, and in next meeting we will see